Welcome to Chemistry at the AM. I'm your host, Joel Sdelka. It's 11:10 a.m. right now. A little breezy outside. It's a high of minus 18 today. Traffic is flowing smoothly on College Avenue, and I see we have a minor obstruction on Toronto Street right now. Oh, the lady is just getting out of the way. Anyways, wheelchair. Anyways, find the concentration. Oh, for those of you live but record, jot this down, pause the video. Okay? We're live again. Find the concentrations of all three of these things at equilibrium if the K value is given. Now, Kc, Kq, same thing. I'm just getting you used to seeing either one. Is 0.4. That's 0.4. We have initial concentrations of everything. Oh, I went through the and for some particular. So, A. I'm going to just say right now, give an algebraic equation that could solve this problem. Normally, I'd have you guys go through it with quadratic equation and solve it, but this year and last year, I've been shortening it up just because, you know, COVID. But you'll have the tools. So initially, I'm going to fill everything in. HI initially is 0. Oh, ICE, right? Initially, the H2 is 1.6. I2 is 2.4. Okay. That's all we have for given information. Here's why you have to use the algebra with this problem. Previous problems, you were always given one of those three for the equilibrium concentration, then you could subtract or add and figure everything else out, right? Just using arithmetic. In this case, we have nothing. So we have to strictly do it by change. So here's what we do. I like to start with one that has a one balanced number of 1 rather than 2. I say, if I lose or gain one of these iodines, you know that it will react twice as much over here, right? But just on a hunch, can you lose anything from the HI? No, so that's the side that's going to be going up. Not just hunch, it's just logic. Otherwise, I would just guess. I'd say one side's going up, one side's going down. And I'd just be consistent. We'll see. Okay. I'm going to say that the I2, I'm going to work with that. I'm going to say I'm going to lose, I don't know how many, but I'm going to call it X. It might be decimal 4 or something. Now, if I take off X of those, the change to H2 is the exact same amount, X, right? So if I lost decimal 4 on this, I'd lose decimal 4 on the H2 as well, right? I don't know what X is, but I do know that twice as much will be changing on the HI side, right? Because the front balance is 2 times whatever value is subtracted on the right hand side. So I just say 2X. And it's a pause. Okay? I'm going to pause here. Everything's still in a 1 to 2 ratio. One side's going up, one side's going down. Any questions about this? So 0 plus 2x is 2x. I'm not going to use the units on here. The 1.6 minus x is just 1.6 minus x. It's an expression. I'm going to just put it in brackets. It makes me feel better. 2.40 minus x. These are our equilibrium concentration expressions. Okay. Are we cool with this? Next. We could solve this. We have an algebraic equation that could solve this problem. Well, we need the K expression. Same as before. I'll give marks for what we did in green. Then I'd give a mark for this. H2 and I2 are the products. So HI squared then yep. I'm going to plug in our expression. I was given the K value of 0.04. I'm going to plug in this K value. And then, of course, I'm going to plug in these expressions. Here, 2x. That's what's going on. 0.04. I'm going to go with that's from given information, then the rest are from our expression. H2 is 1.6. Two x in a bracket. Now, you guys follow the logic behind this? Yeah. Okay. X squared should be. Now, I'll tell you what we're not going to do. We're not going to work past this. This is an algebraic expression. I'll tell you what we would do, though, just because you're going to go into university, you'll be solving. What you would do is then multiply out this part, 4x squared, and then move it up top, right? You'd multiply these brackets, distribution, and you would have a quadratic equation with decimals. X squared and stuff like that. And then you use the quadratic equation to solve. Not too hard, but I'm not going to do it this year. Probably, and I'll give it one more year's rest. Just because the combo of you guys, your math skills, your math classes, you haven't had as much practice and stuff like this. So I'll give you guys a break. Yeah. So that's where this would go. You guys kind of see where this is coming up here, though? Okay. I'm going to ask you, though, a couple questions that are on the handout. Take that over. Yeah. You can leave it because I just said come up with an expression. $5. What Jimmy Jam? Where did I put that little tickle truck here? Maybe I did. Tell you what, I'll get you guys to do just one more of these. See, I can get you with. Understand which one I like best. I'll go with this one. Okay, I'm going to flip ahead. I'll just give you one problem. You know, one I like this. Okay. Can you guys read that? Can you make it bigger? Yeah, I'll have to make it bigger. I'll see about that. Okay. We're going to try this one, just coming up with the expression. We won't actually solve it. The answer is given there, but that's using the quadratic equation. I'm going to see what I can do to make it bigger for you. Just a second here. Give me a break. There it is. Is this big enough? That's about as big as it gets. Okay. I'm going to pause this online, folks. Try this and we'll come up with an answer. Okay, just pointing out something. It gives you the starting concentration. I'm talking to the computer, guys. The concentration of NO is 0.5. The other ones you can assume then are zeros for the ICE chart. I'll pause again and keep you guys working. So right now, hopefully you're getting your ICE chart set up, and since these are zeros, they can't go down. They have to go up. So 1 to 1, so that'll be 1x. So that'll be plus x plus. If this is, and I know it's I'm going to show them. If that's plus x, this side has to be minus, and 2 twice as much, minus 2. It's going to change. That's what this comes. After that, we've got this expression, right? For your equilibrium concentration. Then you do the K expression and plug in your K value that was given in the problem and the X's. And you can leave it at that. So this is what you do, and this is what you do. Right? This is an algebraic expression that would, that's what you'd want for your final answer. I'm not going to make you work it out, but this is what you would do if you did. This is what you guys are missing out on. Okay, but we're stopping here. Okay, so the quadratics stop here. I am going to now instruct everyone here to finish the unit assignment that I've given you, and you can now do the last page. You come up with an expression like that, okay? Those of you on the recording, you're set to go. I think I attached it yesterday. I'll double check on that.